Continue Module 3, learning how to describe distributions of a quantitative variable. We learned in the previous one how to calculate values, measures of center. Here, we want to learn how to describe the distribution, right? And so to describe a distribution, a key idea in the class you see I've highlighted here, we need to know the shape of its distribution. So remember, distribution is how often the values come up. What are all the possible numbers and how often do they come up? So we have shape, center, variability, and unusual features. So a way to remember that is just C, SUV. SUV is a car, C, SUV. Again, you'll come to your own way, but we care about the center, the shape, is there anything unusual, and the variability, which is called the spread. How different are the values? So there are some classic ways to see distributions. One is through this shape here called Bell shape, or normal, or symmetric. Uniform, meaning the data are all kind of come at the same number of values. Here, the data occurs in the middle a lot and then less on the ends. Here you have a bimodal set of data that looks like this, two modes, two high points. And then when you have this kind of long tails, we call these right skewed or skewed right. Positive skewed is another way to think about it. It's in the direction of the tail. Negative skewed or left skewed, right? And so, or skewed left, this is a version of that. So what we look at, and let me show you some examples, some specifics. So this is from the ArtistStat, some sample data. Here's a shape, so that you start to see the shape in the histogram. The box plot also has shape too. You can kind of see how it's nice and symmetric. This would be kind of a normal. This is cereosodium, so the amount of sodium in different cereals, 20 different cereals. Let's pick another one. How about sugar in cereals? And we look at sugar, it's a little bit more uniform, 21, kind of flat. So kind of the same amount of sugar on various sugars. Let's see female heights of students. Again, kind of symmetric, that little normal shape or bell shaped. Let's see hours of watching TV in 2018. A little bit shaped here, but you see there's a tail. This is a right skewed. I wonder if things changed in 2018. I think I put 2018. There's 2013. Yeah, see there's a tail there. Start to see tails. Let's see Airbnb prices in New York City. Let's take a look. There's some data definitely skewed to the right. And so that's what we mean by shape, right, in describing the distribution. SAT scores, kind of flat, really kind of a lot of wide distribution. You could take a look at the box plot to kind of see that too. So we're connecting those examples to these shapes here, but notice we use histograms. We kind of draw lines to approximate those shapes, but we'll be talking about those. Now, something to keep in mind from the last lesson, the mean, when we talk about the mean values, when the data is skewed like this, right, the mean will be affected. The mean is affected by skewed distributions and outliers. So many times in this case, we'll move to use the median, because the median is, as it says, resistant here. The median is known as a resistant measure of center. So that will be the value we'd use. The key thing, again, as we think about is for you to identify the distribution. And so here is a table that kind of summarizes some of the text here, or text you'd see in the book, right? We use the mean, right, when the data is symmetric. We use the median when we have skewed data or outliers. And what happens here, how is the mean affected? It's an important idea. The mean is pulled to the right when you have a skewed to the right. So the mean is greater than the median in this case because it's skewed to one direction. So it's going to be a different value than the mean. If you have skewed left data, then the mean will have a smaller value than the median. So most of the case we would report a median value. And here's an example that we would do in class here. As a practice problem and have discussions. You can see the shape here. You could see skew data here. If you pause the video, you can get the values that we're talking about here. But again, really thinking about the center kind of being in the middle. You see skewed data here for this one here. So the mean value would be bigger than the median in this case. It's harder to find the center because we would use the median, which would be somewhere here. And these values are approximations. Shape, looks like we have some outliers here, not necessarily here, right? Variability means how much spread, how spread out. So in this case, it's from 0 to 60. Here it's from 0.4 to 1.6 if you zoom in or look at your notes there. So something to keep in mind. Now, we're not going to do this class challenge, but I'll leave you with these shapes here. These are approximate shapes for these given situations. If we collected data on the number of miles run by Saturday morning joggers at a local park, our guess would be something like this. And so when we think about this, again, these are really good kind of test questions to analyze and understand statistics and data, not just know how to calculate it. But these are approximate shapes, all based on context, right? The situation that are involved here, the city or the people, right? It could vary, but these were best guesses based on some conversations we had in class.